Let's look at the situations where, for example, we want to test whether the population mean age is 50. How would we test that? We would collect a sample of a random sample of X individuals, N individuals, and we would compute a statistics that we know is a good estimator for the mean of that population, which is the sample average. Suppose that the estimate for our sample is equal to 20. Now, the question becomes, how likely is that this sample comes from a population that has mean equal to 50? One way to think about it would be if our sample average was close to the mean, to the value of 50, we can say that it's very likely that my sample comes from a population that means 50. If my sample average is far away from 50, probably that is not likely. But how can we say how close is close to 50? We have to remember that we're dealing with random variables, so we have to take that into account. So just looking at the difference between 50 and 20 is not going to be enough. Our random variable have a distribution. In particular, the sample average has a sampling distribution with a certain mean and a certain variance. So the distance between 50 and 20 is, in a statistical sense, is not simply the distance between 20 and 50, which is 30, but it also is the distance relative to that distribution of the sample average. Let me give an intuition of why do we need to construct tests in statistics that take account of the fact that we're dealing with random variable. Suppose we're looking at the performance in your courses, and in particular we have two classes, class 1 and class 2. We also know that the mean average of tests at Emory is going to be a B+. And we're going to look at your performance, your grade in your midterms. And let's assume that in both classes, your midterm grade was a B. Now the question is, when should you worry about your performance? How far away are you from the mean of Emory students? Suppose that the professor gives you the distribution of your the test for that class. They both have a mean equal to B+. And the first test distribution is about like this, and the second class distribution is about like this. In both cases, you are just below the mean by 1 grade. The difference from the mean of your test grade is the same in both classes. But clearly, if I show you this, you know exactly that the performance in both classes is not the same. Why? What would you look at? So just looking at the difference between you from the mean is not enough. What you also need to know is what the distribution of the grade is. In particular, what you're going to look at is what is the standard deviation for the grades in that class. Because obviously in the second class, while you're only 1 grade away from the mean, you're about 1 standard deviation away from the mean. While in the first class, while you're still 1 grade away from the mean, you're still within 1 standard deviation and you're still close to a lot of other students in your class. So clearly you would worry more about class 2. This gives you an intuition why when we deal about statistics and we're trying to look at the difference between our statistics and the null hypothesis that we're interested in, just looking at this difference is not enough. What you're also going to start thinking about it is we have to take into account also the standard error of the sample average.